All right, so some key features of an ellipse would be horizontal orientation versus vertical. The vertices are always on the major axis, meaning the longest axis. And then we have co-vertices that would be on the minor axis. Depending on the author, sometimes they're called the minor vertex or the major vertex. The foci, because there are two. Does anybody remember how that affects the shape of your ellipse?
The foci?
I see hands going like this. Yeah, the foci. So let me give you just a little. A circle has one focus. And if I was to pull a string out this far, what would happen is I pull that string around. Be the same distance all the way around, right? Not a perfect circle, but use your imagination. Now with an ellipse, imagine that I tied, a string together, and so it's looped around these guys. And as I pull it tight and go around, as I get up here, wouldn't my string be further apart? So 2, depending on how far apart those are or how close they are, changes the shape of my ellipse. Here is this equation right here. You guys might remember me saying to find the foci, we use cap squared. Is this stuff on your formula sheet, on your fact sheet? Yes? We don't think so? This would be stuff that you need to have memorized then. Let's hurry and do a double check on that.
It is on the formula sheet.
It is on the formula sheet. That is really nice if it is. Ellipse, there it is. They've kind of got it all thrown there in 2 lines though. But it's nice that it's there. Okay, so graph the ellipse. Remember, whenever we have numbers inside parentheses with our variables, we're always going to go in the opposite direction. We've got to do the opposite. So graph the ellipse. We're going to put our center where? -5, -4. Let's see if I can even see those little numbers. 1, 2, 3, 4, 5. 1, 2, 3, 4. Standard form, we love it. So this is a squared. This is b squared. A is always the bigger of the two. A and B can trade places. All these little sneaky things. So on our y-axis, the square root of that number is how far we go in either direction. So what's the square root of 16? So we're going to go 4 up, and we're going to go 4 down. So 1, 2, 3, 4. 1, 2, 3, 4. Therefore, on the x-axis, square root of that number is how far we're going to go left and right. Because this is our x, so square root of 4 is 2. So from the center, 2. Did I go 3 on that one? It sure felt like it. And then Alex has that nifty graph it tool. I did go too far. I knew I did. That's an oops. So in Alex, you're going to plot your center. You'll plot a vertex and your co-vertex, and it will hit beautiful ellipse for you. Now, these take a little bit more work. Graphing is pretty friendly, but then they'll give you this, and they'll say, all right, tell us where the center is, tell us where the foci are, tell us where the vertices are. And I like to create a sketch. It just helps me orient where everything is. So let's start with the center. Where is my center? -3, -5? Okay, so that was pretty easy. -3, -5. 1, 2, 3, 4, 5. Vertices. Which one are we looking for? Are we looking on the x-axis or are we looking on the y-axis? X, right? It doesn't say co-vertices, it says find the vertices. Now because the x is the bigger number, that's why we have that horizontal orientation, right? So our vertices will be on the x-axis. How far are we going? Square root of 169 is 13. Oh goodness. So in this direction, how far would I go? 13. So 3, 13, that would put me here. If that's, I'm going to assume that's 10. So that is what? 10, -5? And in the other direction? -16, -5? And then my foci. Where are they? We didn't really point that out, but the foci sit on the major axis. Okay? And then remember, this is our formula for finding the distance from center. So we're going to use cab squared. A squared minus B squared. How do you know which one is A? The bigger one. The bigger one is always A. So we've got C squared equals 169 minus 144. Oh, they're not always this nice. That's part of what makes this section hard. Your numbers aren't always friendly, but 25 is a pretty nice number they just gave. So C is 5. So what that means is the focus, one focus sits 5 to the right, the other sits 5 to the left of center. How far? 1, 2, 3, 4, 5. So that would be, if we're adding 5, that would be 2, -5. Take away 5, 1, 2, 3, 4, 5. -8, -5. Now just by having this sketch right here, it helps me see my number line. That's really all it does. You guys do not have to sketch it, but it helps me say, oh, we're counting up the y-axis or we're counting across the x-axis. It just helps me anchor what I'm adding and subtracting. Any questions on that one? Okay. Is this a story problem, Britton, that we didn't like?
No, that one
This one was okay? The arch of a bridge. Here it is. A semi-ellipse. It tells me that it is 156 meters long. At its highest, it's 64 meters at the center. And then I've got this point P. It says if you go over this far from center, it wants to know how far is it to the arch. So I need to come up with the equation of the ellipse represented. If you treat this spot right here as 0, 0, that's probably your biggest secret, okay? Because how far is it from center to here?
78.
78. How'd you get there?
156 divided by 2.
Yeah, we just cut it in half, right? It also means it's 78 that way. How far up is it? What does it tell us? Do we have enough information for our ellipse now? We know the major axis, we know the minor axis, and where's my center? What did we call it? 0, 0. So do I have any minus h or minus k? No, it's centered on the origin. So I'm going to have x squared over, what's 78 squared? I need help. That's not one that my brain just holds on to. Actually, you know what I'm going to do? I'm just going to call it 78 squared. Watch me be lazy. Plus y squared. What's that number? 64 squared. And it equals 1. Is that the equation of the ellipse represented? Absolutely. So now the next step is I look at this and it says, okay, what does it say? P is 12. What axis are we on? Right here? Going from center to P? Is that the x-axis? So my x value is what to get to P? 12. So could I substitute in 12 and figure out what the y is? Okay. Once you have your equation, that's half the battle. So depending on your question, watch out. They might want to know the height, or they might want to know the distance over. Pay attention to whether you're substituting in for x or y. So let's see. It tells me the x value is 12. So I've got 12 squared over 78 squared plus y squared over 64 squared equals 1. All right, so I'm just going to do 1 minus. I'm going to take this whole thing away. Then I'm just going to be lazy and have my calculator do the work for me. All right, so 1 minus 12 squared over 78 squared. All right, I've got y squared over 64 squared equals 165 over 169.
Wait, I have a question.
Sure.
Why can't you just put in the square root of 64 squared times by 1 minus 12 squared over 70?
You can. You've just solved all of it in one step. It's perfect. That's the direction we're going in. It's perfect. I'm glad you can see that you do that. Because right now, what am I going to do? I'm going to times by 64 squared and take the square root, just like you said. It's perfect. Let's see, times both sides by 64 squared. So that's gone. Went from a decimal to, from a fraction to a decimal. And then, like Britton said, to get my y value, I need to take the square root of that, right? Second square root of that guy. All right. When we go over 12 meters from center of that bridge, the height up to the top of the arch is 63 point, round to the nearest hundredth, 24 meters. So again, just remember to pay attention to whether you're solving for x or y on those. We are really good at these. This will be newish. Be familiar, but new. So which one of these is positive, which one is negative?
Positive.
So this is positive. It opens to the right. This one is negative. It opens to the left. Now, let's come back up to what we're familiar with. What does the K do? Up and down. What does the H do? Left and right, but because that's a minus, we know that it's always opposite. And we know the A stretches and compresses, right? So now let's relate that to our orientation down here. This time the H is on the outside. So guess what it does? It's going to move our parabola left and right. And the K still is up and down, but because of that minus, we move in the opposite direction. The A is still our stretch and compress. Do you guys remember graphing shortcuts for parabolas? If I say over 1, up 1, over 2, up 4, we're good at that? Okay, we're going to use it. The first thing I would do if I were you is I would look to see what's squared. You looked really worried there, Joe.
I saw the board.
Oh yeah, let's talk about that. I did point this out the other day. So today we have 7173. It is still due Sunday night, and then the Tuesday you come back as your practice test. So you won't see me. That practice test is supposed to be at 91% for 100%. What happens with practice tests? I drop your low, but then guess what? You guys only have 2 more homework assignments after that. Then you like double the class. This is amazing. I can't believe that. It seemed like it was going to be forever, and then all of a sudden it's here. So, Joe, was that your freak out?
Okay.
All right. So, Tuesday, make sure you're here. I don't know if that's one I can extend. So, I'll look at the window, and I don't think that's one I can extend. Okay. So, back to this problem. I would look at what's squared. If it's x squared, we're good. We're really good at it. But if it's y squared, that's the new stuff, right? So notice I've got 2 y squared problems here just because that's what's new and I wanted to practice that with you. All right, so y squared. We know that our parabola is tipped this way or this way. And it's positive, so that narrows it down to it opens to the right. First thing you want to do is figure out where your vertex is. Now remember, they're opposite, right? Because we've tipped over. So what does the -4 do? Yeah, we're going to move left. So 1, 2, 3, 4. And what does the -5 do when it's associated with the y? We're going to go up 5. 3, 4, 5. Make sure that makes sense. How did I get my vertex there? Moved it left, moved it up. That's the hardest part. Okay? That is the hardest part. So now instead of counting over and going up, we're going to count down and go right. All right? So if we go over 1, 1 squared is 1 times 3. 1, 2, 3. Over 2, 2 squared is 4. 4 times 3 is 12. So I've got to go to 8. I think that's it. And then I just reflect it on the other side. Now, your Alex tool on these, this is what it's going to do. It's going to say, click your vertex. You plot it, and then it says, now click which way it opens. So you know it opens to the right. You'll click somewhere over here, and then it asks you to just plot 1 more point. So those are super friendly. Yep. So if your A is negative, yes, it would open to the left. Would you like to do one more graph of parabola? We're good? We feel good about that? Okay. This is new. This is something that we didn't spend any time on last year. It's a different form of a parabola, and it helps us know where the focus and the directrix is. And have you guys ever heard those words before? So focus, yes, because we just talked about the foci of an ellipse, or the focus of a circle, right? A parabola also has a focus. And this directrix is kind of fancy schmancy. Let me show you how they're related. You could pick any point on your parabola. Let's go with this one since it's graphed, our vertex. What do you know about this distance from here to here? They're both p, so they're the same. They're equal to each other. Now I could pick any point on my parabola. Clear over there? The distance from the focus to that point is the same as the distance to the directrix. Wow. Any point from your focus to the directrix is the same. So I will find when you're doing your homework, there's an animation of showing how you could graph a parabola using distance from directrix and focus. So that's where that comes from. You will want to pay attention to these. Again, watch which one is squared. If your x is squared, you know it opens up or down. If your y is squared, you know it opens left or right. So far so great. It's got that fancy 4 in there. 4 times p, what is p? Remind me. Written right here, and I didn't even talk about it. P is your distance from the vertex to the focus, or your vertex to the directrix. Okay, that is our distance of P. So over here, we've got our parabola. Again, sometimes it just helps me to sketch it and know what I'm looking at. All right, so I've got an x squared. Which way does it open if it's an x squared? It opens up or down, right? Up or down. This guy is negative, so I wonder what that does. Here, P is negative. Here, P is positive. So what's happening to our vertex, or to our parabola? Which way does it open? It opens down. Yeah, opens down. So let's plot our vertex first. Tell me where to go. -1, -4. Both of them are opposite. That was perfect. 1, 2, 3, 4. So -1, -4. Focus. This is new. Over on the other side, we had that this was 4P, didn't we?
So 6/4.
Yeah, so how did you do that? You're right. Tell me how you did that.
Well, if 4P equals -6.
Okay, let's write that down. If 4P equals -6,
Then P equals -6/4.
P equals -6/4, or P is -3/2. Perfect. Perfect, perfect, perfect. So they use ugly numbers again, so don't be afraid of them. Don't think you're doing anything wrong. If my vertex is right here at -1, -4, which way did we say it opens?
Down.
So we know it opens this way. Okay. Which one does it ask for? The focus? So I need to go in this direction because the focus is inside, right? The focus is inside the parabola. So am I adding to the x or the y value? So we've got to do, here, I'll come down here, -1, and then we've got -4 -3/2. All right. So that would be -1, what would that be? 8, -11/2. Okay, and then our directrix sits out here. So if we went in this direction 3/2 to get to the directrix, we need to go the other direction 3/2. So see how sketching it just helps me know if I'm adding or subtracting? That's the only reason I do that. Am I adding or am I subtracting? So this way would be -1, we've got -4, now plus 3/2. So we're going up the y-axis. So, oh, it just wants the equation, right? Hello. What is -4 plus 3/2?
-5/2.
-5/2. So this point right here is -1, -5/2, but it wants the equation. The line goes this way. Is that an x equals or a y equals? So it's a y equals, what did we just get? So y equals -5/2. Axis of symmetry. Do you remember where that is?
That's just the X.
That's just our x in this case, right? So that would be an x equals, what was our x value that we're working with? X equals -1. Would you like to see another one? We're all feeling a little overwhelmed. All right, we won't do another one of those. I'll help you with your homework. How's that? Alex added something this year that I haven't ever paid attention to anyway, if it was there before. They tell me how long a problem on average should take. And I looked at this one. Anybody want to guess how many minutes they give for that problem?
30.
Not 30. It is definitely less than 30.
5, 10, 12.
It was 14 minutes.
Per problem?
14 for this story problem right here. Yeah. I don't know if that's to pass off 3 or if that's just for one problem, but I was like, man, that's kind of intense. Do you remember once you knew the secret to our bridge problem over here? It was like, all right, that was good, right? And 0, 0 was a big part of that. It's going to be the same thing with this headlamp thing they've got going on, or the spotlight, whatever it is in this case. A lamp has the shape of a parabola. The lamp is 40 centimeters wide, 25 centimeters deep, and our light source sits right here, and that's the distance it wants to know. It also says a key word in there. Where does it sit? It's placed at the focus. So what are we solving for? And there's a fancy letter for the focus. We're going to be solving for P ultimately, right? So if I could come up with the equation of this parabola, could I solve for P? Yeah. So let's see. If our vertex is at 0, 0, do I have anything going on with the x or y squared? Nothing, right? Because I've got the 0. So it opens up. So let's go back to our little formula here. If it opens up, which one are we doing? This guy? All right, but we already said the h is going to be 0 and the k is going to be 0. So we will have x squared equals 4p times what? Times our y. Was the y squared?
Yeah. Oh, no.
Let's look again. Let's just double check. Uh-oh. You guys have already looked. I can't find it. Right? Which one had the y squared? We're getting the two confused because they gave us ellipses today, right? So remember, only one of them is squared when we're working with the parabola. So, I've got 3 unknowns. I'm solving for P. So if I happen to know an x, y, a point that I could plug in, could I solve for P? Do I have a point? I don't know if 0, 0 will help me. I'll get 0, 0 back. Do I have another point? 20, 25? All right, so I can say 20 squared equals 4p times our y. 20 squared is 400. 4 times 25 is 100. So P is 4. So what did it want to know? It wanted us to know how far away it is. How far away is it? 4. How far is the light source from the bottom of the lamp? We just solved for P. So from 0 to there is 4 centimeters.
Wait, that's all?
That's it.
Wait, look.
That wasn't 14 minutes, was it?
It won't always be. Yeah.
0.
It isn't always 0, 0. Is that what you're telling me?
Like, half the version right there. That's always confused.
So what does it give you? They are going to change for sure.
Right, so I have like the 0, 0, and I have the focus, right? I don't know the X value.
Okay, you don't know the X? Okay, so let's talk about this. So we'll still sit here at 0, 0. It tells you this is what?
That is 5 inches.
This is 5? And then we know this is 0, 0. What else does it give you?
45 is the height on the lead.
So somewhere right here is 45?
Yes.
All right. So we still have x squared equals 4py. What can I replace the p with? 5. Is this an x or is this a y?
That is it.
So what can I replace the y with? And what am I solving for? And so you just solve for your unknown that way. So they do shake it up for sure. I'm glad you asked that question. Okay, do not beat yourselves up trying to do this all at once and thinking you have to figure it all out. Let me help you. You guys aren't always super great at asking questions and let me help you with your homework. So do in this section. Okay.